Okay, this is the Math 1401 Zoom meeting for Monday, March 15th. And this week we hit section 7.2. And it's a very long section. And I regret in my schedule only giving 1 week for it. It's almost too much. Not hardly enough for 2 weeks, but it's kind of almost too much for 1 week. We're scheduled to have a test on this with 6-1 at the end of the week. I don't know. I might reconsider that as we go on, but let me just charge in. Practice problems out of the book are page 347, problems 5 to 51 odd. Again, right now the test on Friday will be based on them. All right, the MyLab problems. The problems on MyLab are kind of all mixed up. And so I went through them. You can pretty much categorize them or organize them into 4 groups. And these are my names for the groups. They're called I call them forwards problems, backwards problems, forwards word problems, and backwards word problems. And that's why it's all 4, doing all 4 in 1 week is, I've never taught this online before. This is my first time through the entire course online. And it's hard to know how much time and everything it's going to take. And I have a feeling a week is going to be too short. We might have to take this into next week. All right, so here's what I'm trying to tell you. I highly recommend you work the problems in this order because to me, it makes the most sense. And this is the way, by the way, the book is organized. But they scrambled up the problems on MyLab.
Okay.
All right, for whatever, the book homework is organized this way, but the MyLab did not seem to be. It seemed to be all scrambled. So I went through all the problems. There was 51 of them, if I remember. I think I cut it down to 24. Don't thank me all at once. Yeah, don't thank me all at once. Only have you do 24 of them. Okay, so I highly recommend that you work the forwards problems first, and that is these off MyLab. Now that probably makes no sense at all. You have no idea what's a forward problem. That's what I'm going to get into and explain. In fact, tonight's video, I think I'm just going to give you the introduction to this and then just work forwards problems, and that'll be just tonight's video.
Yes, please.
I may make more videos about the other 3 kinds here and send them around for everybody to watch.
Yes, please.
To try to be more prepared for the Zooms at the end of the week. All right. But in any case, the second I would work, these are called backwards problems. Again, I understand that makes no sense at all right now. But these second and then third forwards word problems, these, and then finally number 4, backwards word problems, these. And it may take 2 weeks to do this. So email me the percent of these 24 that you get correct.
Yes, please.
Okay. Again, you won't find those names in the book. They're my names.
Yeah, I understand.
Right. And so I'm going to explain why I call them each of those names. And it's complicated enough. I think we'll just get through the forwards tonight. That'll probably take 30 to 45 minutes. And that will be enough for tonight. Okay. 7.2 is about continuous probability distributions. Okay, they come from chapter 2. From a large number of data. Okay, so I'm just going to give you an example, my stock example. We're going to take 5,000 people. We're going to measure their height. make up a chapter 2 table. Remember, we called it a frequency distribution table. And I'm going to assume that, here's the classes, no one was smaller than 5 foot. That's 60 inches to less than 61. And 61 to less than 62. All right, so this is going to go on down. And so height, we're going to make this, let's see. Well, this is the height. Oh, I'm sorry. I meant frequency. Class, the height is over here. All right, let's say there was 90 people here, 180 people here. These are the frequencies. All right, and then the relative frequency, we would divide, this will total up to 5,000, however many people were here. And we're going to divide each of these by 5,000. Divide by 5,000, 0.018. 180 divide by 5,000, 0.036. And this goes on down. Questions so far?
No, please.
Okay. So what happens is we're going to make a histogram. And so we'll call this 0.02, 0.04, et cetera. And 60 to less than 61, 61 to less than 62, blah, blah, blah. And so 0.018 just short of 0.02 and 0.036, and it looks like this. And this will go on. Okay, but here's what you got to realize. This is not a picture of the entire set of data. There's a whole lot of data here. We're starting with the short people, and we're going down to tall people. So the whole data set looks like this. Turns out height is symmetric. That means there's just as many tall people in the world, super tall people, as there are super short people. So it turns out that it looks basically, try to draw it basically symmetric, and then blah, 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 to these beginnings. And over here, you have really tall people. Okay, something like this. This is height. Now, what I have done here is I've basically graphed the first 2 bars, and I have zoomed in on the first 2 bars and blown them up, and this is what you get. Questions about this?
I really don't understand.
Okay, so let's back up, because I basically am doing nothing so far from just chapter 2. I don't know, maybe just not confused. Let's see. On the high end, the really tall people, I might have had somebody, let's say 7 feet tall. What's 7 feet? It's 84 inches. 84 to less than 85 inches or so on. Does that help? Maybe I had 90 people in that category. The point being, this is a very large number of data. And because it's so large, I really don't want to take the time to copy it all down. 5,000 people is very large. I don't want to put in all the categories. So I'm just trying to show examples of the first couple of rows right out of chapter 2. There was 90 people in this interval. There's 180 people in this interval, maybe 90 people in this one. When I divided each one by the total, I got these relative frequencies. And you
Okay.
remember drawing histograms out of chapter 2?
So the plotting of the histogram, are you using the relative frequency or are you using the,
I'm using the relative frequency.
okay.
But I'm telling you, here's the leap.
So you use the relative frequency and the height, right?
On the heights.
Okay.
And so what I'm trying, the leap is, because I haven't shown you the data, the leap is that the entire data set looks like this. Average height's probably 5'8", which is like 68 inches. This would be like 68 inches. And so most people around average height, around 68 inches. This is back to 60 inches or so, 60 to 61. Over here, you're at 84 inches, say, 7 feet tall. But the bars look like this. Height is symmetric. Turns out height is symmetric.
Okay.
And it just means there's as many people 7 feet tall as there are 5 feet tall, roughly. Okay, we want to parallel chapter 6, which means we want to, they're going to ask probability questions.
Okay.
So I'll just remember what they did in chapter 6. It's 6.1. You had a table and you could only use whole numbers. This is probability 0.2, 0.4, et cetera, right? They might ask you, find probability that X is 1. Probability that X equals 1. Can you tell it's 0.4? Ah, we have another participant. Very good. Appreciate you coming out tonight. Mr. Augustine, yeah, we're doing continuous distributions here. This is the intro to it, and then we're going to show you how to work the beginnings of the problems of this section. There's 4 types of problems in this section, and we're going to do just first type tonight.
Okay.
Okay. So this in 7.2, see how the table looks like this in 6.1?
Yes, please.
Okay, so you could read the probability, right?
Yes, please.
Well, in 7.2, the table looks like this. So you would ask, find probability that you're 60 to less than 61 inches. Can you tell you would then be
0.018.
0.018? Okay, so that's the parallel question from 6.1. All right, but the rub is there's something else going on. You were allowed to use any number between 60 and 61. Somebody could have been 60.1, 60.3, 60.4. There's theoretically infinite possibilities. So what happens is the 0.018 is the height, and then you're at 61 on this edge, you're at 60 on this edge, and you're allowed to use anything in between, and that width happens to be 1. So you're actually multiplying by the width there, the 1, because you're allowed to use any number in there. And this is, let's say, the height, and this is, say, the width. But the point being, one dimension times the other dimension is equal to an area under the curve. Have either of you had any calculus?
No, please.
Okay,
No, I've not done calculus.
Hadn't had any calculus. Okay, no problem. This is explained in calculus, and I'm trying very hard. We have to teach this class without calculus, so I'm trying very hard to teach this without using any calculus. But the point being, in a continuous situation, I'll write this down. In a continuous situation, probability equals area under the normal curve. So in the book and in my lab, they're going to give you your normal curve or bell curve. And they'll ask, find probability that you're less than, I'll give you some number here, negative 1.1. And what they mean is this area equals the area to left of negative 1.1. I'll point to it, this area. And so we're going to be drawing a lot of these diagrams and shading to zero in on this area. And the purpose of tonight is to give you the absolute basics about how to find this. You actually need calculus to find it. So we're going to show you the tricks that we're going to use to get around calculus to find it. We're going to find it without calculus. It's a neat trick. All right, questions about this?
Don't have any.
Okay, so to proceed, we need to give you the properties of the normal curve. Next, we need the properties of the normal curve. They're actually found in 7.1, but we're not going to assign anything from 7.1. It's just 7.1 is just baby problems, and we're not going to assign them. Don't thank me all at once. But the properties that we need are there. I'll find them here. Right. Page 332. All right, I'm not going to write all of these down. I'm just going to highlight the ones that are super important. Page 332, number 1, normal curve is symmetric about the mean. Okay, number 2 says the mean equals the median equals the mode at the center. Y'all remember that? We actually hit some of these in chapter 3.
Yes.
Please.
I remember all 3 words were identical at that center. Okay. Number 3, we're going to ignore. It's about inflection points. That's a calculus concept. Number 4, we hit in chapter 3, total area under the curve equals 1. You remember me telling you that in chapter 3? I called it the ancient Chinese secret. Remember we had a table, we had a K value, 1, 2, and 3. Y'all remember your percentages? It was called the empirical rule. This is chapter 3. 68, 95, 99.7. This ring a bell? It does to me. You see the useless stuff I have in my head?
Mhm.
This ring any sort of bell?
Yes, please.
Okay. And so you remember we wound up on some of the problems subtracting the percentages from 1.
Yes, please.
Okay. All right. So number 5 is very important. Area to right equals area to left equals 0.5. I'll redraw it. 0.5, 0.5. See, that's a consequence of property 1. The curve is symmetric. And if the total area is 1, it's got to split 0.5 and 0.5 about the y-axis. We're going to use this property a lot. Questions about that?
None for me. I'm looking forward to the application.
Okay, yes, it's coming. You just need these properties. We're going to use these properties to find these probabilities.
Okay.
So they're very important. You need to know them. And the very last one, number 6, the tails never touch the x-axis. We'll just say number 6, tails never touch the x-axis. Redraw it again. Remember, this is your left tail. This is your right tail. They approach, they never touch here or here. I'm just paraphrasing. They give you like 4 lines to say this. Okay, moving right along. Now we need the formula for the normal curve. It looks like this. We did show you this in chapter 3. I don't know if you remember it. That ring any sort of bell, or has it been flushed? Okay. I don't know if the reason I showed it to you in chapter 3 is, remember, we played around with the exponent and we got the z-score formula. X minus mean divided by standard deviation. That ring a bell?
Yeah, I saw it from there. Yes.
Yes.
We're going to use this a lot. This is going to come back and we're going to use this a lot. Okay. We're going to normalize this. It's also called standardize it. And that means set sigma equals 1 and mean equals 0. Standard deviation 1, the mean equals 0. Let's plug those numbers in. 1 over 1 times square root of 2 pi e to the negative x minus 0 squared over twice 1 squared. Can you see how it shrinks? See, basically with ones, you can ignore it. Your front becomes this. We usually slip a 1 in and make it a negative a half. And can you see, basically that 1 squared disappears and x minus 0 is just
0.
Well, no, x minus 0 is
0 is x. Yes.
x squared. So this whole formula shrinks to this.
Okay.
Now, in my summer classes, when I've got like 3 hours a day and got to kill some time somehow, I make people enter this on your graphing calculator and prove that it really draws a nice, pretty bell curve. Do you all need to take time to do that, or do we all believe?
I believe. I'm a believer.
You believe. All right. Because it would take about another 10 minutes to enter all the stuff on the calculator to prove it to you. So, but I don't need to do that. We all believe. Okay. That's the formula for the curve. Now we need the formula for probability. Looks like And it involves this, so I'm trying to keep them both on the page. It involves this. Probability looks like this. All right, since neither one of you have had any calculus, this probably makes no sense whatsoever. But this is a calculus, can't you spell calculus? Calculus formula for probability in a continuous situation distribution. This formula, calculus is universal truth. It has been known since the 1600s. And it is the only correct way to find probability in a continuous situation. But we can't use calculus. People haven't had it. So how are we going to get around it? And by the way, this formula would find, I'll draw it down here. Remember we said probability was like you form a thing and they're going to show you lots of pictures like that. It would find an area like this. I'll show it to you.
Okay.
If you had calculus, I could show you how to punch this formula in the calculator, same one we use, and compute that area. But we don't know calculus. Oh no, what are we going to do? Someone very smart who knows calculus and who has absolutely no life whatsoever punched his way through this formula for a bunch of different numbers.
Oh,
And he
log
wrote
table.
his answers down in a table.
Okay.
The
Like-
tables are very long.
Oh yeah. This
Yeah.
table is in the printed copy of the book.
Yeah.
I'm sure it's at the back
Yes.
in a fold out. And I'm sure it's in the electronic copy of the book.
Yes.
Okay. If we were in the regular classroom, I would actually print out copies and give them out. Because the rest of this session is going to be about the very first part of using this table, and I call it forwards problems. Notice it comes in 2 pages. We're going to show you how to use both pages. And basically, we are plagiarizing this person's calculus answers. It's as if we told him, punch this in and let us copy it. And we are copying it from this. Okay, it's taken 35 minutes to get through the intro. Are we ready to charge into the very first kind of problems? These are called forwards problems.
Yes, please.
All right, let me pick them out of the book. Now we're switching to 7-2 homework. I call these forwards problems, but you won't find that name in the book. I'll explain why I use that name here in a minute. Page 347. he doesn't give a lot of practice in the book. That's why I assigned, a lot of the MyLab, because you'll find a lot more practice about this in the MyLab. But again, when you go to MyLab, try to work them in the order I've put on the assignment. If you just work them random, the way they're on the screen, it's all scrambled. I don't think it'll make any sense at all. So I'm tried to organize the MyLab exactly like the book is organized. All right, so our first example, I'm gonna stick to some of the even ones, let y'all mess with the odd ones. Page 347, what's not example, exercise. Let's go problem 6. There's a lot of parts to some of these. Okay, I'll put it up here. It says, determine the area under the standard normal curve that lies to the left of, and then they give you some of these numbers. All right, I'm gonna start with B. I'm gonna write that down. Determine the area under the normal curve. They call it the standard normal curve. To the left of z equals negative 1.99. This probably reads like complete gibberish. So let's try to make sense of this. Draw a picture. Cannot emphasize that enough. I always draw pictures. Pictures look the exact same way. Normal curve. Zero's at the center. Negative, just like a number line, negative numbers that way, positive numbers that way. So negative 1.99, it's got to be over here somewhere. And you've got to be left of that. They want it to be the left of that. So I'm going to draw straight up to the curve, shade to the left. Any questions about picturing these conditions? Very important.
No, please.
Okay. So we don't know how to use that calculus formula. So let's talk about the table. Notice the table, the picture at the top looks very similar. They just have a general Z number here, it's called. Okay. What you really should do with this table is twist it horizontally. Because what happens is these Z numbers, I'll put them right up above the, these Z numbers actually run right across. They're giving you the Z numbers right along the axis. Until you hit 0 here, that's actually in the center. So it's really being labeled from negative 3.4 to 0. Negative 3.4 here to 0 in the center. Well, where's the other side? So glad you asked. It's on page 2. So when you switch to page 2, this 0 here is starting right here in the center. And you're going all the way to positive 3.4. It just looks vertical on the paper when you do this. Questions about that? Okay. The columns across the top are labeled by hundreds places. So if you want to be really technical, the leftmost number you can look up is negative 3.49, and the positive known one is positive 3.49, technically. Okay, this is part A. To work any of these, you work them all the same. After you've pictured it, you work all of these the same way. You split off the number at the hundreds place. So you split off the hundreds place. This side is your row. So you come over and you find negative 1.9, and it's right there. And your 9 you've split off here is your column, 0.09 column. So we go over to negative 1.9 row, 0.09 column. And do you see the number where that negative 1.9 row intersects the 09 column? That's the number we write down, and it's the area of this black left. It's like we looked up negative 1.99 for that, and that's the area of this, 0233. Questions about that?
None.
Okay, before we go on and do any more, this probably seems like complete gibberish to you. So let's see if we can stop and understand exactly what all these gibberish numbers mean. Do you understand what the negative 1.99 means?
Yes.
Right, we have one person who does. Does our other person understand what it means?
Yes, it means 1.999 is the shaded area to the left.
Okay, well, that's just what they gave you. That's the problem. But what did the Z mean? Again, go back to chapter 3. Remember that we gave you a table K, 1, 2, and 3?
Yes, please.
68, 95, 99.7.
Yes, please.
We stuck to 3 whole number, although I think they gave you a 2.5 in there on one problem or something. But basically, you stuck in chapter 3 to only whole numbers. Well, now we've relaxed that, at least to 2 places. So this negative 1.99 is your number of standard deviations away from your mean. In this case, 1.99 standard deviations below your mean.
Okay.
Okay, so it's exactly, this was 1 standard deviation from the mean, 2 or 3 from the mean. This is negative 1.99 from the mean. Okay, that's what any Z number down here means. Do you understand what the 0233 means?
No.
Okay, there's 2 meanings. It is the overall percentage of the numbers. Remember what this meant? 68% of the numbers are within 1 standard deviation of the mean?
Yes, please.
Okay, here 2.33% of the numbers are below this many standard deviations from the mean. You've got 2.33% of the data left or below this many standard deviations. The other interpretation, close your eyes, and there's a 2.33% chance that you'll pull a number from this interval. Do I need to write any of that down?
I got it.
Ms. Obase, you want me to write any of that down?
My worry is where is the 0.0233 come
Where
from?
is it? You're asking where is it?
Where is it? Where is it coming from?
Okay, let me show you again. This was given in the problem. This is kind of an arbitrary Z number given in the problem.
Yes, please.
So I split off, I'll give you the instant replay. So I pictured the problem. They wanted negative 1.99 is to the left. This is always 0 at the center. They wanted it left of that.
Yes, please.
I split off the 9.
Okay.
You find this in the Z column. but it's actually your row. So when I look in the Z column, I'm looking down for negative 1.9.
Yes, I've
Yeah.
seen it, but how do you get the 0.0233?
This number over here is read 0.09 because it's in the hundreds place.
Okay.
It's your column. So if I go along that row, lift it up so you can see it better.
Okay.
See, it's in the 09 column. Does that help?
Yes, please.
Okay, let me do 2 or 3 more because this is very repetitive. So once you see 2 or
Yes,
3
please.
of them done, it's very repetitive and it should make a lot more sense. Go ahead.
So on the left side of this of the table you are holding, you look at 1.9, right?
Negative 1.9.
At the left, yes, you look at 1.9, right?
Negative, right. The sign's very important because you see if it was
Okay,
positive,
negative 1.9.
right, because if you see it was positive, I'd be using this sheet and get the wrong number.
Okay, then you follow it to the right.
Yep. Well, I follow it over to whatever column I need. And the column
Okay.
I need is determined by that number in the hundreds place.
Which is 0.09, right?
0.09. So
Okay.
when those intersect, the 0233 right there in this column on that row, that is the percentage of the data left of this 0233. Think of it as the area of the black.
Okay.
So I'm shading this exactly like it's shaded on the table. So think of that number as the area of this black region.
Okay.
Let me do the next one.
Yes, please.
Yeah, we've beaten this one to death. By the way, I have my own pet names for these tricks. These are called, I call this using the table forwards. When you find your row and you're in this, your row, and then you come over to whatever column, I've called that using the table forwards.
Okay.
And by the way, the trick for this, I call this direct lookup. This is the first trick. There's like 4 forwards tricks. I call this one just a direct lookup. Try part B. I'm sorry, C. 6C, left, determine area that lies left of 0.92. 47, problem 6C, find area left of Z equals 0.92. Picture it. Zeros at the center. Which side is 0.92? Is it this way or this way?
Near the center.
Well, it might be near the center, but is it on the right side of 0 or on the left side of 0?
I think the left
On
side.
the right side.
0.92 is positive.
Oh, on the left side.
On the left side.
Okay. 0.92 is positive. You know, don't confuse this with this.
Okay.
The 0.92 is positive, right?
Yes.
Yes.
Which side of 0 are positive numbers?
Right.
Yeah, right.
Over here.
Okay.
But you want,
That's true. No negative in front of the 0.92.
There's no negative in front of the 0.92. Your 0.92 standard deviation is above the mean.
Okay.
But you see, you want the area left of that. So you go up to the curve and you want all of this.
Oh,
Okay.
Okay. You do the same thing. Split that 2 off. Split off the hundredths place. Your rho will be at z equals 0.9 and 0.02, that's your column. But you see, you're going to be on page 2. You see 0.9?
yes.
Yes, please.
And then we wanted, try to get both page on, you want rho 0.9, so that you come down the z to rho 0.9, and you want the O2 column,
0.8212.
0.8212. And I label it up here, just like that, 8212. 82% of the data are left or below 0.92 standard deviations above the mean. It's a mouthful. If you punched your way through that horrible calculus formula, you would get this answer.
Professor, can we get like soft copies of this log table? Because I remember we call it log table in Africa. I don't know if it's what it's called here.
Well, it should be in your book,
Okay.
but if I made myself a note, I could probably be persuaded to mail it out to you. Would that be helpful?
Okay. Yes, thank you. It would really be helpful.
Okay. Mail out normal table. Okay. You want to see one more trick like this?
Yes, please.
This is called direct lookup. All right, try D. Problem 6D. Z equals 2.9 left. Z equals 2.90. Well, which side of 0 would 2.90 be?
Right.
The
Right.
Yeah, the right side. Again, I like to picture it, so I shade the whole thing to the, remember you want left of that. Split off that 0. You're at rho 2.9.00 column. Row 2.9. And the 0, try to get, see the 0 column is the very first one. The 2.9, 0 column.
99.81.
99.81. And again, that is the area of the black, left of it always. 99.81. 99% of your numbers are left of that. Okay, there are 3 other forwards tricks. You've seen enough of this trick? You ready for the other 3? We're at 55 minutes, so yeah.
Yes, please. We're ready for the other tricks.
All right, so these are all still forwards problems, but you wind up using the table tricky, depending on what they want. Look at problem 8, page 347. Find area to right of values B, Z equals negative 0.55. I call this the right side trick. Which side, remember that's 0, which side will negative 0.55 be?
The left.
Yep, be over here. And you want to shade to the right of that. That's all of this. You work all forwards problems the same way. Split that 5 off. This is your row, negative 0.5. Your column is 0.05. So I'm going to be on page 1. I want negative, try to get both things on. Negative 0.5. It's down toward the bottom here. You see negative 0.5. And then I want the 0.5 column. Oh, can I get the whole thing on? Negative 0.5, 0.5 column. Can you see it? What number do you see?
I think it's is it the one up or I can't see where.
Tough to get the,
Okay.
if I zoom in for y'all, like you can't get the whole thing on the page, but here's the 0.5 column.
Yes, please.
All right, so I've come down to the negative 0.5 row. What number do you see?
The one the pen on top is on top, right?
Yeah.
0.2912.
912. Now
912.
remember, that's the area of this black, always. That's not my answer.
Okay.
That's this way. That's why I call these tricks. 29% of the numbers are below that, left of that. But I wanted it to the right.
Oh, subtracted from 1.
Oh, I think I heard it. What'd you say?
You subtracted from 1.
Outstanding. You picked up the trick. See? The picture tells you what to do. So yes, the area would go, it's like a complement situation.
Yes.
2912. You're either below it or the complement is that you're above it because the total area is 1. So reach for calculus because I don't really want to do that by hand. Reach for calculator. 1 minus 0.2912 is 7088. 70% of my numbers. Well, you could call it 70.88%, or you just use a direct decimal out of the book, 0.7088. 0.7088 is this way. And that is the answer to this one. So you see how it's a slightly different trick?
Yes, please.
Yeah.
The first set of problems, they wanted area left. So when you split off, that was you looked it up in the table and boom, you didn't have to do a thing. That was your answer. That's the easiest thing to do.
Huh.
So when they want area to the right, you do exactly the same thing, but you got to take what you look up and subtract it from 1. So I call it, this is the second trick of the forwards problems here. Do you want to see more tricks like this? Or is this enough for this trick? And you ready for the next trick?
Yes. Ready for the next trick.
The next trick, please.
Ready for the next trick? The next trick is between 2 Z numbers. Try number 10, page 347, problem 10A. Find area between Z equals negative 2.55 and 2.55. I'll flash it up just to kind of paraphrased it. But area under the curve between negative 2.55 and positive. So you got 2 different Z numbers. Which side is negative 2.55?
Left side.
Left side. Negative 2.55. Which side is positive 2.55?
Right side.
On the right side. You want to go between them. While having a sliver of area between those. Questions about the setup?
No, please.
Okay. You work this exactly the same way. Split off that 5, look it up, split off that 5 and look it up. You'll need both pages. Are you seeing how to look stuff up? You probably don't have the table in front of you, but this is your O5 column and you're on negative 2.5 row. Row, O5 column. So negative 2.5. O5 column. See the number?
Yes. 0.0054.
0054. Remember, that's the area of the black. Left. That's why it's very important to label this. 0.0054. Can you tell that obviously has nothing to do with my shaded area? That can't be my answer, right?
Oh,
I want the area of this shaded region. This is clearly not it, right?
yes.
Yes.
Okay. So let's play the same game with this number, but we got to go to page 2. Positive 2.5 row, O5 column. Positive 2.5. So here's the row, O5 column. See it? Yeah, see, there's the O5 column down to the 2.5 row. And what number do you see?
0.9946.
And remember, that's the area of this black all the way to the left.
Yes.
So I'm gonna come up here and put that on. Yeah, gummit, short-term memory. What was that thing? 9946, right?
Yes.
Okay.
Yes, please.
9946. So 99% of my numbers are all the way left of this, and 0.5% of the numbers are all the way left of this. Well, neither one directly is my answer. What do I do with these? Can you tell? Or is it only obvious to me? You see, if I'm 9946 all the way to the left, and then I've got this much left of this is inside this. What do you think I should do with them?
Subtract it.
Very good, subtract them. So I'll be going 0.9946 and subtracting 0.0054.
Still 9.
0.9946 minus 0.0054, 9892. That's what's in the middle here, like 0.9892 between here and here. Questions about that? You're going to do that between any two Z numbers. You want to see another trick like that?
I'm good. If all the questions revolve around these 3 questions, then we are good.
Okay. Ms. Obey, do you want to see one more like this?
No, please. I'm good with this.
Good. Okay. You ready for the last trick?
Yes, please.
Okay, last forwards trick. I call it the two-tail problem. Let's try problem 12A. determine area left of negative 2.94 or right of positive 2.94. Find area left of 2.94 or right. I'm sorry, left of negative 2.94 or right of positive 2.94. All right, so we draw our picture. Negative 2.94 is on the left side. Positive is on the right side. So we see it says go left of that. That would be this. Right of positive 2.94 would be this. You see where I get the name two-tail problem?
Yes, please.
Okay. You work these exactly the same way, split off your hundreds place and write down where the stuff should appear, and then you got to read the picture. So when I split off this 4 right here, I'm looking at this row,
0.9.
negative 2.9, and then the O4 column, negative 2.9, O4 column. Can you tell it's 0.0016?
0.001, I think 16.
16. Remember, that's all the way left. Now you can tell, see, that directly matches up with this shaded region. That's part of my answer. But I got to come up with this. So if I split off this 4, 2.9, O4 column. Hard to see the column. Can you tell? Through O4 column. 2.9. What did you see what we're getting?
I can't really see where.
Right above my pen there.
Okay, 0. Is it 0.9984?
84. Now remember, that's the area of this black. So I come up here, and it's 9984.
Okay.
Now, can you tell I don't subtract them? That would give me the middle. That's the last trick.
So now you adding?
I eventually, but I got to get to this. See, the 9984 is the wrong side of 2.94. How do I get to this?
Subtract from 1.
No, it's a combination of like a right side trick. So yeah, I got to go 1 minus 0.9984, and that will give me this.
Okay.
Oh, wait a minute, 0.0016. Wait a minute, that's the same as this. How can it be?
Yeah, it's the same.
Yeah, they're the same. How can that happen?
Because they are the same numbers, just at the other side of the mean.
They're symmetric. Remember property 1, the curve is symmetric, right?
Yes,
So yeah,
please.
if these Z numbers are identical, they're just switched in sign, you got to get the same areas or percentages either side of them. Yeah. Now, we're not quite done. See this word or? Remember from chapter 5, what did or mean? It meant add. Right? So what do you think I got to do with this and this?
You are.
Add them. So my actual answer will be 0.0016 plus 0.0016. 0.0032. There are other ways. This is not the only way to do it. There are, you could play it. You could subtract this and this, and that gets the center. But then you got to do what? You got to take that away from one to get what's outside. You see, you could play it that way if you wanted. There can be multiple ways to do these things.
I think this way is okay for me.
Okay. I play it, this is a combination of trick one, directly looking up on this side, and this is a right side trick. And then you got to subtracting it from one to get to the right side, and then you got to wind up adding them because you got two separate pieces. That's all of the forwards tricks. Took an hour and 15 minutes. Whoa, okay. That is all the examples of forwards tricks. The book will not tell you this, that's why I'm here, but you see this problem 13?
Yes, please.
It seems so simple. Gee, find a z-score, blah, blah, blah. There's nothing to tell you that this works completely different. It's the second type of problem. I call it backwards. So in other words, it kind of works backwards to these first set of problems. I won't go into that tonight. We're an hour and 15 minutes. It's late. But I think I will make some videos about that to try to help people. Because otherwise they're kind of blind. Remember, there's three other kinds of problems. There's backwards, and then you got to do forwards word problems and backwards word problems. I think I'll make some videos to try to help people if I can get anybody to watch them.
Please, it will help.
Okay.
Yes, please.
Sure. Does anybody want to, you want to see any more forwards kind of problems? That's all it's a matter of reading what they give you, drawing the picture, being able to look up, splitting off this place, put the numbers down where they should go, always left of what you look up, and then reading the picture. You want any more examples?
I'm good with the forwards.
Okay.
I'm okay.
Okay, well, if you got any questions, email me, let me know. And yeah, on the video, I may do a few more examples of this before I do charge into the rest of it. But all right, well, it's pretty late. I appreciate y'all coming out. Thank you very much.
Thank you, sir.
Okay.
Thank you.
Good thing. Y'all have a good night.
Thank you. And you
Okay.
too.